Hey everyone, welcome back to CompilerSutra. In last video, we have explored what is OpenCL and how to install OpenCL in our system. In this video, we are going to discuss about how to run basic OpenCL code in our system. So let's get started. Before we directly jump into the concept of how to run our basic OpenCL code, here are some foundations which we should be aware of. These foundation concepts will help us to understand how the OpenCL works. To run OpenCL program, we should be aware of following 5 points. First, what is kernel? Second, why do we need kernel? Third, OpenCL platform model. Fourth, device model. Fifth, context command queues, how CPU and GPU share the data. In this series of how to run basic OpenCL kernel, let's first understand what kernel is and why we need kernel. In OpenCL, kernel is a function which is written in C-like language which can be run across your different devices, CPU and GPU. Think of kernel as a core piece of code which you want to execute in a parallel. Let us assume you have two array A and array B, both of size 1000. You want to add this both array and store the result in the C. What you will going to do?
Statement. We have a total 3 array A, B and C, each of size 1000. We have to now add element of array A and element of array B and store the result of both elements into the C. So for that purpose, the simple snippet will be Ci equals to AI plus Bi for 0 to 999. What here actually is happening, we are reading the element of array A and array B. After adding them, we are storing the result in C. If you have a very basic coding idea, then you can write a simple for loop. What that for loop will be look like is showing on the screen. What our aim is to do. Our aim is to add element of array A and element of array B and store the result in element C. So this will be done by this simple snippet. Let's understand in detail what is happening in this snippet. How this will work, let us understand. The loop will run 1000 times, and each time if you go through the computation, same set of steps. So let's understand in detail what is going to happening. In the initial step or step 1, the value of the I will get initialized to 0. Here we are initializing I to 0 and this will be executed by the CPU. In step 2, we are checking the condition where I is less than 1000. As we have to add element of array A and array B, only 1000 element, as the size is 1000, so we have to iterate loop from 0 to 999. Array index start from the 0, not from 1, so we have to iterate till 0 to 999. That's why we have written here less than 1000. So this condition will be checked. As we can see that currently I value is what? 0. As I value is 0 and 0 is less than 1000, so that's why condition hold true, it will go inside this statement. It will executed by the CPU. At third, what will happen? This line will get executed. We will execute Ci equals to AI plus Bi. In this case, I value is 0, so it will become C of 0 plus A of 0 plus B of 0. It will be executed by the CPU. At fourth, what will be happening? At fourth step again, I will plus will get executed. Value of I will become 1 because we are incrementing I by 1. I value of this will be executed by the CPU. After this, again the condition will be checked. Now I is became 1 and it again less than 1000, so this loop will be true. So it will again go inside this condition. This loop condition hold true as now I value is 1 and is again less than 1000, so it will again go inside the body of the loop. So it will again execute Ci equals to AI plus Bi. Here I will become 1 and A1 plus B1, where it will be again stored in the C1. So this way it will continue till 999 till I become 9. As soon as I become 999, last element of this array, then again after that increment will happen, so it will come as 1000 less than 1000, which is not possible because 1000 is always equal to 1000. So this loop term condition will become false and our code will come out of the loop. This will also execute. Finally, when I become 1000, condition will fail and it will execute out of the loop. On the left of the screen, we can see two array A and B, each of size 4. A has element 1, 2, 3, 4 and B has element 3, 4, 5, 6. What is our goal is we have to add each element of A and B and store in a new array C. So the final output of the C will come as C equals to 3 plus 1 4, 4 plus 2 6, 5 plus 3 8, 6 plus 4 10. This can be done in two ways. First sequential and second parallel. First look at how it works sequentially at a time using a single thread or core. So here are the basically steps if we have a single thread or a core, how the sequential operation will look like. In step 1, we will compute C0, which will be A0 plus B0 and we get a result at C0 equal to 1 plus 3 and result will get stored in array C as like this. In step 2, we will compute 2 and 4 as C1 equal to A1 plus V1. This will store in C1 as 2 plus 4, so it will come as 4, 6. In step 3, what we will do, we will add 3 and 5 and the result will come as 8. And step 4, we will add A3 and B3. So the value which A3 and B3 is having is 4 and 6, so it will become 10 after addition. So 4, 6 and 10 will come. Now let's see the same task how it works in parallel. Now let's look how the same task will work in parallel using 4 threads. Each index of the array will execute simultaneously in one step and in one go. So the final result will become 4, 6, 8, 10, which is much faster.
When it comes to OpenCL, instead of doing sequential operation, we write a code in such a way that it executes parallelly. With OpenCL, you can launch 1000 kernel parallel. So basically what kernel is? Kernel is your code and logic in OpenCL which you want to run and execute parallelly across hardware. Basically kernel we can think of as code and logic which we want to run parallelly, and OpenCL as an infra which will help us to launch that kernel in parallel. So in this video we got a clear idea what kernel is. In upcoming video we are going to see how to write a basic kernel and kernel in parallel.